Welcome to the latest episode 106. This is your host, Dr. Jenny Chen. In today's episode, we had a great conversation with Dr. Aadeel Akhtar, the visionary CEO and founder of Psionic. Join our in-depth conversation around the world of advanced bionic limbs and explore how Psionic is revolutionizing its prosthetics technology on both humans and robots. So sit back, relax, and get ready to be inspired.
Please listen to the disclaimer at the end of this podcast.
Hello. Welcome to the pod, Aadeel.
Yeah, thank you for having me.
Well, I look forward to this interview for literally years. And finally, I feel we're ready. We're ready for you.
All right.
So, everybody, this is an incredible interview that I've been waiting. This is the CEO and founder of Psionic. And for those who don't know what Psionic is, you will soon.
Yeah, so what we do at Psionic is we develop advanced bionic limbs for both humans and robots. And so it's a prosthetic hand for people who are missing them. And it's also the same hand that goes on industrial robot arms and humanoid robots. And what we build for humans benefits robots, and what we build for robots benefits humans.
Awesome. And, for the 3D printing community that we typically talk to, prosthetic hand, prosthetic limbs aren't a strange topic. How do you differentiate psionic arms or ability hand from all these other 3D printed prosthetics that we see every day?
Yeah, and the thing is that this is the hand I'm holding right here, the ability hand, right? This is the 9.5th generation of the hand that we've developed over the last like 11, 12 years now. And the first like four hands were entirely 3D printed, like fully 3D printed, using like PLA and ABS. And we started that way. It was really great because it made kind of building devices accessible, like more accessible than ever before. And when we started, it was around like 2013, 2014, when like MakerBot was becoming like really huge at the time. And so there were like communities growing online through Instructables and Thingiverse. And we found like early open source designs from like InMove and like Open Bionics, where we were like, hey, these are like interesting like models of like hands. Can we start there and see what we can build? And then the next three versions of the hand, so Mark 1 and Mark 2 were based on open source designs we found online. And then Mark 3 through Mark 5, we started designing ourselves, and we open sourced those. So anyone can find the instructions to build those versions online. And what was very interesting was that we thought that, just by building these like super low cost 3D printed hands, that this is going to like revolutionize everything. And then when we started talking with like actual patients and customers, the number one thing they complained about wasn't necessarily that the hands were like super expensive. That was a problem.
Right.
But it was more so that they were breaking their super expensive, like $50,000 within a couple months of using it. And that was disrupting them a lot more in their daily lives than just not using a hand at all. And if we gave them one of these 3D printed hands, then they would have broken the thing like within a minute of using it. So we had to figure out how could we still leverage the low cost of 3D printing, but then make this hand more robust than anything else that's out there. And we came across soft robotics, the whole field of soft robotics. And at Yale, they had this group there called the Grab Lab, and they have this like soft robotics toolkit where they were like using low cost silicones, like 2-part silicones you can buy from Smooth On, and then using 3D printed molds to like make all sorts of like cool like robots that were flexible and compliant, like your own fingers are, right? And so we started using some of those techniques of like, hey, can we use silicone and rubber? And we would 3D print like a bone inside of the fingers, and then we would overmold it with the silicone in a 3D printed mold. And these fingers are flexible, so I can take it, I can like smash it, and it survives the impact. We've done like flaming board breaking with it, where I had 3 wooden boards set on fire, punched through it. I've dropped it off the roof of my house. It survived. I put it in a dryer.
We need
for
some
2 minutes.
videos. We need some
Oh yeah,
videos to insert as a B-roll for this.
and all of those are on our YouTube channel too, right?
Yes.
And so we learned that if we could use 3D printing in a different way to build these soft components and reinforce them with materials like carbon fiber. So we have a 3D printed palm underneath here, and we reinforce that with carbon fiber, that we can build something that's super durable and super strong, but still also low cost to make and easy to manufacture.
I think I made a mistake asking you a question because this is like 10 years of work, of research, and maybe even more than that of work, and not just prosthetics, but also neuroengineering, all compressed into 1 hour episode. So it's okay if we can't unpack all the important concepts, but I think that's a very good timeline. Just give people a concept of how much work was put into this in the last decade to come to the version, the 9.5 today. And also, I remember you had an infographic with all those versions in one picture, right? Or
Yeah.
something like that. I'd love to actually include that in our show notes so that people have a concept. Yes, you can only look at it, but it just represents all the different conceptual evolution behind this hand. Now let's roll back a couple decades earlier when you were still young, Adeel. What inspired this whole thing? I mean, you really bet big your life onto this whole project of creating psionic ability hand and its related technologies. But let's roll into the origin of the company and what started it.
Yeah, I've been wanting to build bionic limbs since I was actually 7 years old. So my parents are from Pakistan, and I was visiting, and I was born in Chicago. But when I was visiting, that was the first time I met someone missing a limb. She was my age, living in
Yeah.
poverty, missing her right leg and using a tree branch as a crutch. And that's what inspired me to go into this field. So the original plan was to become a medical doctor who worked with people missing limbs. And I went to Loyola Chicago, got a bachelor's degree in biology there, a master's in computer science. I taught there for a couple of years, and then I went to the University of Illinois at Urbana-Champaign, got another master's in electrical and computer engineering, PhD in neuroscience, and then I left medical school to do this because this was a bit more fun than finishing medical school. But also, we could make a much stronger impact through a company than we could through academia. And it was while I was doing my PhD, we got the chance to go down to Ecuador, where it was Mark II of the Ability hand. So this was the summer of 2014. The hand was fully 3D printed, wires going everywhere, breadboards, power supplies the wall. The hand was 3 times the size of an average human hand. And despite that, Juan, our very first human user of the hand, he had lost his left hand 35 years prior due to a landmine explosion. And he made a pinch with his left hand for the first time in 35 years in front of international news stations and said he felt as though a part of him had come back. And when he said that, that's when I realized that if I stay in academia, this just ends up as a journal paper. If I finish medical school and work at an academic hospital, that's what becomes of this. If we want everyone to feel the same way that Juan did, we had to commercialize this technology. And so that's when Psionic was born.
By the way, you're famous in University of Chicago. I don't know if you know that.
Really?
Yeah, apparently you're the most famous engineer coming out of that. I mean, according to my intern, Peter.
Yeah. All
Yeah, he's
right.
he's at
That's
UC
exciting.
right now. Yeah. You still teach at the school, right? Or
Yeah. So
occasionally?
I'm affiliate faculty at the University of Illinois as well as at the University of California, San Diego.
So, okay, now that you wanted to form a company as everybody else from the academia, what was a deal like, you know, was it 2015 that you started the company? What was the
Yes.
year? What was
Yes.
the deal like 10 years ago?
What was the
What were you
idea?
like? What were you like? I mean, you were
What
just a
was I
fresh
like
PhD.
years
You
ago?
haven't even finished it back then,
Oh,
right? You didn't even finish your PhD
yeah, I
before
didn't
you,
finish.
yeah.
Yeah, I finished my
Well, wait,
PhD.
now you finished, but back
Yeah,
then you were still in the middle of
yeah.
completing. And so
Uh,
was that? What was that like wanting to form a company?
it was definitely daunting. And so it's funny because that Ecuador trip I took, my wife usually refers to it as like I went down as a student and I came back as a CEO, and it was really
Wow.
interesting because I mean I never viewed it from that perspective, but she's seeing it from like that external perspective, and I was like, huh, that's
Mm-hmm.
that's quite interesting. The thing is that I'd seen so many research projects, like so many theses and dissertations that were so promising and so exciting, just never happened, like beyond just getting published. And that was the end goal of it. And then they just sat on a shelf. And I was like, if we had that kind of reaction from one of our very first human users, like we need to commercialize this technology. And so we started entering like our school's business plan competition and started like going through the National Science Foundation I-Core program, which basically helps teach engineers how to like translate their technologies over to like real world product market fit, talk to as many customers as possible, find out what the real pain points are. And that was I mean, it was fun because it was like learning a new language. Everything I'd learned up to that point in time was all very either scientific or engineering based, but it wasn't like very business focused. And we wanted to make that impact. We needed to learn the business side of it too. And like, how could we turn this into a sustainable revenue model so that we can help more people as we continue to grow? So it was a lot of it was also just we had this very specific goal in mind. We want to get people in our hands. So it's like we're going to do whatever it takes to get there. Whether it's start a business, like figure out how to build these hands, like work with as many patients and clinicians as possible, and then also now expand to the robotic side as well too to help increase the volumes and subsidize the cost for the human side as well.
Yeah, so just I'm super interested because a lot of our audience are still in the lab and want to form their companies. How did you what I mean, I know it's a very slow progressive process to turn from academia to commercial to entrepreneur like you are today. You're definitely one of the most polished speakers I see in the public domain, I have to say, and you are through trial of fire. So I'm pretty sure day one, Adeel, you're not that smooth, but the first, I would say 24 months of your company inception is probably exciting and at the same time scary. How did you survive that period of time and transform yourself?
Yeah, and honestly, the pitch now is nothing like it was like back then, right? And it took a lot of iteration and practice, right? I mean, like I've probably given not like exaggerating, probably over like between 1,000 to 2,000 pitches over the last like since the existence of the company, right? And now, especially because we're raising our Series A round and doing that, I'm pitching like 3 or 4 times a day, right? Like every day, and a lot of it's just like it's reinforcement learning, right? You do it and then you suck at it and then you get feedback and then you keep improving and improving and improving and improving. You see what resonates with your audience, like what are the things that are making their eyes like light up and like stay interested, what are the things that they're just glazing over and they don't care about, right?
Hmm.
uh and during those first, one of the things that has always been with us from the beginning is having a compelling demo, like a demonstration of like the product, even if it's like a really like not well put together demo, but something that's moving and it's working. Like even from the early days, like even when we had all those wires connected to like the breadboards and all that stuff, I would hook up the hand to my muscles and I would like control it, and then it would people could get it. They understood really easily like exactly what we were doing, right? Having that demo was like a critical element from the start. And I don't think, Jenny, I don't know if you've ever seen me not carrying the
I was
hand.
gonna say, yes, you and that limb, it's probably that's your third limb, actually, your
Exactly.
third
Yeah,
upper limb.
extension of my body at this point, right?
Yeah.
I mean, to the point where I can tell like what grip someone is doing just based off the frequency of the motors. Like I've become so attuned to the product that yeah, it's it is like a part of me, right? Both like all like physically and mentally in that regard, where I understand like all the ins and outs of it and how to do different tasks and everything with it. I mean, obviously, I'm not someone with a limb difference, and their experience is going to be completely different than mine and how they integrate it into their lives. But by being able to at least have an intimate knowledge of our products and work with a lot of our human users of it, we know exactly what the pitfalls are. We know what we need to improve. That is that reinforcement learning, that iteration that needs to go into it, that we started from the very beginning in those first 24.
Yeah. And then initially you mentioned you joined a lot of government funded programs to get funding and experience. The first couple years, is that mostly the non-dilutive funding where like, the grants supported your projects ahead? And when was the point where you started to say we can really start to sell this product?
Yeah, so we got about 4 NSF SBIR, so Small Business Innovation Research Awards, and I think it totaled to around like 2.7 million or so at the end of it all. And so that was really our lifeline from the beginning, like
Hmm.
when we started the company. And to give an example, in the summer of 2017, we spent that in Shenzhen, China. It was me, my wife who was 6 months pregnant. It was our 1.5-year-old son, and then like 4 of my undergraduate students, all in a high rise in Shenzhen. And only one of us spoke Chinese, and it was not me, and it was not my wife. And so we found like, our early motor manufacturers and our gear manufacturers there, and then we're able to rapidly prototype on like electronic circuit boards. And we decided to do an Indiegogo campaign to raise
Hmm.
funds to kind of fund that.
I
And
see.
we were going to raise $250,000 on this Indiegogo campaign. And we ended up raising $7,000. So it was a complete and utter massive failure, right?
Yeah.
And at the end of that year, we had $200 left in our bank account. And the following week, well, so that month we learned that we were going to be getting our first NSF grant, the SBIR award. And we were thinking like, do I need to go back to medical school? Do my students need to go to grad school, etc.?
Well, medical school is not going to get you there. I'm telling you. That's slow. That's very slow.
Yeah, but I mean, is Psionic going to live, right?
Right,
That
right,
was that,
exactly.
that was
Near
the
death experience. Yeah.
exactly. And then we found out in December we were going to get that grant. And literally the next week we had $200,200 in our bank account. And it was more money than we ever had before, right? So it's like this been this like roller coaster ride of like low lows and high highs, and but it's
Hmm.
been like increasing the entire time. So we're fortunate on that front.
And also, you had a family
Yeah,
already
exactly. And
and a newborn.
yes, I we incorporated the company um 10 days before my firstborn, a son, was born. So yeah, my wife jokes that Psionic is my baby, and then like Zane, my son, is her baby.
I have to comment that your wife must be a very calm person.
She definitely is the one that keeps me sane and motivated to do a lot of this stuff.
But then I started Indiegogo. That was a fail. But you didn't stop there. You also participated in other kind of crowdfunding platform. You didn't give up.
Yeah, yeah. And so we got the SBI awards, and that got us to the point where we actually got a product that was like ready. And so we talked with a lot of clinicians. We had them test it out with patients, and then
Hmm.
one of them in particular, Dave Rotter in Chicago, he's like the best prosthetist in the entire world. And he like designed Roger Ebert's jaw. He does like Tammy Duckworth's legs, are the senator.
Wow.
And so he had seen every iteration of our hand, and he said everyone was a piece of junk up until that one.
Wow.
And exactly. And then he finally was like, okay, you might be onto something.
Hmm.
And we went through him, fit our very first couple patients, and got it covered through insurance. And then that was around, and we did like a limited release in the Midwest, and that was like
Which
around
version was that? I mean, which
that
version
was
of
Mark
the
8. That was Mark.
8? Okay. And what was the feature that really impressed him?
It was the durability.
I
That was,
see.
and he was the one that told us that. He was like, if you're going to build something, you need to build it to be durable, right, and impact resistant. And the other thing was that the fact that we got covered under Medicare, that was like that. So the price point was a huge thing for him. And then eventually, like this is the first hand to give users touch feedback. The speed is the fastest bionic hand on the market as well too. So those were additional things that when people saw that, like they were like, oh wow, it moves so fast, it reacts so quickly to my muscles, that it really got them to like like lock into the device itself. So we started that like limited release. Around that time is when we raised a pre-seed round. And so we raised it from like angel investors, like I think it was like around 1.4 million that we raised from angel investors. And that brought us to our nationwide launch of Mark 9 of the Ability Hand.
Hmm.
In the summer of 2022, that's when we were really, we needed to expand. We needed to take this to the next level. We needed to hire a bunch more people. And we were still in Champaign, Illinois and we were looking to grow and move to the next place. And so we are thinking of either like Chicago or San Diego or our top two choices. And we ended up going to San Diego primarily because we're working very closely with the Navy hospital on the next generation of these devices that are directly connected to your bones, your muscles, and your nerves, as well as UCSD is a great school over there as well. We've got like the big military population. We've got the Paralympic Training Center and the Olympic Training Center like 40 minutes away from us. The Challenge Athletes Foundation is close by. Huge med tech community. But no one was building devices there, like at least bionic hand devices and prosthetics. And so we were like, we can go there, develop like the devices, and then bring all of this community together to turn San Diego into the bionics capital of the world. And
Hmm.
around that time, that's when we were raising our seed round. So we started a seed round like in 2023. And there was, I think the Wall Street Journal said at that time it was like the worst time in history to like raise from like VCs. And we were like, okay, well that doesn't bode well. And we half of our sales at the time were coming from social media, which for a medical device is not common. And we were like, we've been burned by crowdfunding before, like the Indiegogo campaign did not go well, but we're in a much different situation than we were last time, right? We've got like way better assets. We've got like way better like connections and networks than we did like 4 or 5 years ago when we were doing the Indiegogo campaign. And so we decided, you know what, let's give this a shot again. And right off the bat, like we had like videos of the hand walking on its own for Halloween. We had like the arm wrestling and the flaming board breaking videos. We had another video where it was like the Boston Dynamics dog with 2 arms built by a professor from the University of Illinois. And then we put our hands on it and gave it lightsabers. And they had a lightsaber duel against the
I
Boston
think I
Dynamics.
saw that one before. Yes.
Yeah. And like these all like, just fed the viral flame, right? And allowed us to continuously raise through Start Engine. And for us, the most beautiful thing was if we're a company that's about accessibility, right? Why not make the company itself accessible? And the most beautiful thing was that our own patients got to invest in the company. So they got
Amazing.
part of us building this for them. And we ended up raising 4.1 million on Start Engine, which I think is one of the largest crowdfund raises that they've had. And it was just really exciting to see that. And that's what ended up getting us like on the Shark Tank, right? So like ABC called us and they were like, "Hey, we think you'd be good on the show," and so we ended up like filling out the application, auditioning, and then appearing on the show and making a 3 shark deal, which was just like we never would have thought any of that was going to happen. We couldn't.
Yeah, no, I don't think you ever shied away from a single interview. You're always very enthusiastic and, always speak with passion. I mean, your passion is very obvious through your just everything, every presentation. Now, first of all, I just want to mention, I thought you were in San Diego for some other reason, but the beach is there, the surfing culture, but never thought of the Navy station there and all the other patient population.
I'll say the beaches don't hurt. The weather is beautiful out here.
Um, well, at the end of the day, you are selling really cutting edge technology. So without the technology actually working, obviously no amount of marketing can help. So let's dig a little bit deep into what your ability can do. Well, first of all, why did you name it 9.5 and not just straight 10?
Yeah, so a lot of it was upgrades that we did on the main like structure of the Mark 9. So every generation of the hand that we do is basically like starting from scratch and like rebuilding the entire thing, right? And so
Interesting.
0.5, we didn't like rebuild it entirely from scratch. It was more so improvements that we did on Mark 9. So we made the fingers conductive, we made the fingers stronger. The silicone is more robust.
I see.
The internals are much more robust and easier to produce as well too. And then like we updated the logo to be like a chrome reflective logo on the back. So it was just a lot more polished version of Mark 9 from everything that we had learned. And now we're working on Mark 10 of the Ability Hand, which that's going to be like redoing the entire thing from the ground up based on all the learnings that we learned from the robotics customers and our human users as well too.
What do you mean by ground up?
Yeah, so starting from the actuators, we're going to have different motors in there. We're going to have like a new gearing system. We're going to have like updated like electronics and encoders in there. We're going to probably be adding more degrees of freedom in the hand too, so more motors as well. And so that's a completely new design, like entirely from
Wow.
what we have right now in the Ability Hand. And so it's going to be really exciting the new features that's going to unlock and enable in the next generation hand.
So from your version 8 to version 9, that's also a kind of revolution, new refresh of the old version. Okay,
Yep,
I see. Got
exactly.
it. And then I definitely dig deep into what are your core patents are, which means the things that really differentiate you from any other competitors. And a lot of concepts really require unpacking a little bit because I would say a large portion of our audience is general public, and they probably don't understand some of the key components of the MK hands. Well, first of all, why so some of the major features you mentioned, including the very fast speed, the zero point 0.2 seconds. I mean, if you tell me 0.2 seconds, I know it's very fast, but I have no concept of how to compare this, to others. Another example of this is 30, I mean, the touch sensors, I get it too. Um, I mean, 30 versus other numbers. Again, I'd love to just hear some of these key features, like how do you compare it to other products on the market that's comparable, and what is the significance of these?
Yeah, absolutely. And so we have like several patents that revolve around one, the flexibility of the fingers, right? So we've got a compliant full bar linkage mechanism that makes the fingers very flexible, right? So that's why I can take it and I can smash it and it
Hmm.
survives the impact.
I see.
So we have another
So
one.
that's part of the durability that you're talking
Yes,
about, the
that exactly.
compliance.
That's
I
part of the
see.
durability and
Okay.
the
Makes
compliance.
sense.
And so
Yeah.
then we have another patent on the brushless motor control technology that allows our fingers to move at like in 200 milliseconds, in zero point 0.2 seconds, you can close a finger. So to put that in context, you blink your eyes in about 300 milliseconds. So it's technically faster than we
Mm.
blink our own eyes.
Wow.
And then secondly, it's about 2.5 times faster than other hands on the market. That
What about human hand? I mean, how fast can we open our and close our own
Yes.
hand?
So human hands can be around like 75 milliseconds.
Wow.
So you can go faster with a human hand still. And we're trying to like draw that balance, right? Because there's a trade-off between the speed that you have and the amount of strength that you have because of the
I
gear
see.
ratios that are in the gearbox. And so because of that, we didn't want to go so weak that we would be like ultra fast, but then like you can't like really grab onto anything strongly,
Mm.
right? And so now we've got like 18 pounds of grip force, which I think a human hand maximum, like you can do way more than that, but like 40 pounds was like typical. But 18 pounds is enough to do like most activities of daily living. But then we can move the fingers at 200 milliseconds, like twice as fast, more than twice as fast as these other hands, so that you can get that response time well enough. And then, so that's the speed aspect. And then the touch sensing. So this was the first bionic hand on the market to include touch sensors. And so we have six in each of the fingers. So there's one on the fingertip, one on the finger pad, two on the outside, the two on the inside. And then that relates to a vibration motor for our human users. So when you touch here, they can feel a vibration.
Mm.
So, like when they touch an object, when they've let go, and how hard that they've pressed on that object, and so by being able to give that feedback back to users, that was already a huge thing. Our very first patient, Sergeant Garrett Anderson, he lost his hand in Iraq in 2005 due to a roadside bomb. Sorry, he was our first U.S. patient. Juan was our first patient, the one in Ecuador. But
Mhm.
he told us that he could actually feel his daughter's hand, and
Mm.
that's something that you couldn't do with any other prosthesis before, right? I mean, and that those moments, that's why we do what we do, right? That to improve those the quality of life for individuals with limb differences, and so, yeah, I think we're still the only bionic hand, the prosthetic hand with touch sensors built in. On the robotic side, there's now a ton of hands that have like touch sensors built in. There's a lot of growing competition coming from China in particular too, with just hardware that's coming out. We still have like state of the art hands and performance and like stability and consistency and things like that. But one of the things that makes us unique is because it's the same hand that goes on humans that goes on robots, we can
Mhm.
actually train the robots to do the same tasks that our human users can do from the data that we can then collect from the hand through our programming interface.
Yeah, I mean, in terms of the haptic feature, is this a feedback loop? I mean, let's say, your amputee is wearing this arm and you can feel something, a vibration. How does that convert into future actions, like what we do now?
Yeah, so for example, our human users have grabbed raspberries without crushing them, right? Because they can detect like as soon as they make contact, they get a vibration to know that I've grabbed this raspberry. Holding like flimsy cups of water, right, or like a drink, right, without crushing it. That's another example of like where it's been really important to get that haptic feedback. So that you can do these really delicate tasks, but then our hand can hold 100. They can then go to the gym and then like do a 100-pound kettlebell swing, and that's totally fine. So it gives them like the dexterity and like the feeling to be able to do like these very delicate tasks, but then also have the confidence to go out and like lift weights.
So, if I'm grabbing a raspberry with your hand and I feel I'm grabbing too hard, do I just relax my upper arm muscle or something like that to release it?
Yep,
Okay, I see.
where you
It
would
is kind of,
contract in the opposite direction, and that would like open it up a little bit.
I see. That's amazing. Okay. Also, one the other innovative component of your hardware system is that you use an open source API. So, can you explain the significance of that?
Yeah, so on our GitHub, we've open sourced our programming interface, our API, And you can stream all 30 of the touch sensors over Bluetooth, over USB connection, as well as control the position, velocity, and torque of all six of the motors that are in the hand. So that controls flexion, extension in all five digits, and then also the rotation as well. And then we can also feed all of that information back as well. So the position, the velocity, and torque over all six of those motors that are in the hand. So what that our robotics customers and our researchers, they're able to get set up with the hand in less than 5 minutes. So when
Hmm.
they get the hand, they can just use our API and in less than 5 minutes get it working and then start programming it. And that's really critical because then our customers can basically get going on what they want to do with the hand, whether it's like an industrial pick and place task or if it's folding laundry or if it's activities of daily living that humans might be doing.
Yeah, apparently folding laundry extremely difficult for current robots.
That's right, but not for our human users of the ability hand.
Has any of your patients actually trying to program their own hand using your API? I'm just
Actually,
curious.
yes. One of our human users, so his name is Loyal Pasinski. He used to run the show systems division at Disney Imagineering. So
Mm.
basically, all of robotics at Disney Imagineering fell under him. And now he's like, I think he's like the head of metaverse, like emerging technologies at Meta. And so he's missing his hand. He was born without a hand, and he got our hand for both personal reasons, so that he could use it as like a prosthetic hand, but also so he could program it and using our API to do like really cool stuff. And one of the interesting things that we saw him do recently was that the Meta, like I think he was using Oculus or the Meta glasses or something, where
Hmm.
yeah, he was actually able to get them to recognize the hand on his on his left side
Wow.
as like a natural hand. And so he could finally do bimanual tasks in like VR in a way that he'd never done before because he'd never had a hand on that side. So that was really exciting to see like him do that, use it in a professional setting in addition to his personal life.
Another far out question, since we're on top of talking about dexterity, do you think these robotic hands can eventually be trained to do something a lot more skilled, like surgery?
Yeah, I think so.
Wow. Really?
I don't think it's gonna happen in the next year. I think it's gonna be in the next, like, 5 to 10 years, but I definitely think that that's in the realm of possibility, especially with the, improvements that we're seeing both on the hardware side and on the AI side. I think that that'll be doable.
Just a joke. When I was a medical student, since I have no skills as a surgeon, I was in the operating room and my job was to retract the opening of the
Uh-huh.
surgical field.
Yep.
And it was the worst job ever. And you get yelled at if you're not doing it right or fall asleep, which I did.
Ah,
But imagine you have a robotic hand to gently pry open the surgical field. You don't really need me there.
and you know, I think sooner than that though, I could really see like surgical assistance, like being able to just like hand someone a tool, like a surgeon the right tool, and
Yeah.
I think that is going to be something that we will see in the next like couple years even.
So yeah, we mentioned a lot. We discussed a little bit about the human robot flywheel that now you're actually opening up your horizon in terms of future customers. Now, I mean, obviously your origin was human prosthetics for patients. That's a huge market. And the second one now you just started is going to the industry. When did that started? Like how did you decide to make that pivot?
Yeah, it's interesting because from the beginning we were already selling into the robotics space. It just wasn't as
Okay.
large as it is now. And I came from a robotics lab, so my PhD, even though it's in neuroscience, it was actually in a robotics lab. So we always had a sense of knowing like what robotics people wanted, and that's like why we had an open source API because we were like that's something that researchers in robotics and human side would want as well. And so when we like launched this nationwide at the end of 2021, beginning of 2022, Meta was an early purchaser of our hand, and they put it on a robot arm so they could do like reinforcement learning tasks with it. But that was like 4 years ago that they started doing those kinds of things. And it was like, I would say though, over the last couple of years, there's just been like an exponential increase on like the robotics side, where it's kind of like, even though both sides are growing as a business for us, we see more business now on the robotic side than on the human side, just because it's been exploding so rapidly over the last couple of years.
Yeah, actually, we did a little bit economic study a couple years ago in the prosthetics market in general is there's a lot of physical and economic factors that limit the size of the overall market for prosthetics. One is most people who are missing limb are usually in healthcare scarce countries, that people don't have access to proper healthcare and or war-torn countries, I mean, the amount of people who are missing limb in our country, in the United States, for example, is probably on a relatively small size. So that definitely has a little bit limitation there. So of all the robot that are now in the industry, so what are some of the most exciting projects? I mean, if you're allowed to disclose, I know I understand there's some stuff that completely in secrets, and I don't want someone to follow me around
Yeah,
after this podcast.
I would say some of the automotive applications have been really cool.
Hmm.
For example, Mercedes is using our hands to do like build cars essentially through Apptronic's humanoid robot, and
Hmm.
they've got a bunch of videos online where they're using like tools like a electronic screwdriver to like drill into like the chassis, as well as put really complex shaped parts together as well too. That has been one of the coolest things to see that our hands building cars. And then on the human side too, there's just been some like really incredible things as well. Like some of the things that our human users have been able to do. So most recently, one of our more recent human users of the hand, he lost his Jamie Groshon, he lost his hand due to a fireworks accident a couple of years ago, and he was going to play Division I baseball on a scholarship at San
No.
Diego State, and that ended that for him. But last year he got our hand, and we had him throw out the first pitch at the San Francisco Giants game. But then we
Wow.
moved to this childhood baseball diamond, and I threw out a bunch of pitches to him, and he ended up hitting the world's first Bionic home run, and the subsequent nine home run, like the next nine after that, as well.
Wow.
And it was just so incredible to witness this because he didn't know he could do it. I didn't know he could do it. And for us to like then learn like that, some of these limitations exist more in our heads than we think, that
Absolutely.
it was just incredible to witness what can be enabled.
Yeah, as much as the market overall size compared to some other industry is small, I want to make sure I emphasize that there's large potential still in the prosthetics market because not every patient is actually have access to your hand.
Exactly, and I mean, there's 10 million people worldwide who are missing hands. And the thing is that with the volumes that we see on the robotic side, that the prices will go down
Hmm.
enough that
Yeah.
I think it will actually hit a price point that will work in a developing nation.
Yeah, I like to hear a little about that. You're scaling up, and how do you make this more affordable to a lot of people, patients?
Yeah. Yeah, so one way is just through pure volume, right? So the manufacturing at scale, like, then we can, get, like, costs even lower, then, like, prices even lower too, but, we've also started initiatives in particular. One of those initiatives is called the Ability Fund, and this is in partnership with the Range of Motion Project, a nonprofit organization. And, every, $25,000 that's donated to the Ability Fund will completely cover the entire, like, the cost of, as well as all the medical services, all the clinical services to get a bionic hand fitted to an individual. And then on top of that, it will actually donate a leg to someone in Guatemala or in Ecuador. So it's like an arm and a leg for 25K. And this is typically like 100,000 to $150,000 worth of services and devices.
Hmm.
And so for us to do that, like this has been an incredible service that we've been able to provide, and we fit our first two patients on that already. So our first one was Ivan Krastev, who was born without his left hand. He was bullied as a kid for not having a hand, and
Hmm.
then he saw, like, one of his teachers showed him one of our videos, and he was just like, he's in South San Diego, and he's like, I need to visit him and see like this in person. And he brought his a high school robotics club over to Psionic, and we hooked him up to muscle sensors. And for the first time in his life, he controlled a hand on his left side. And then a year later, he was one of our investors actually donated the 25K to fund him to get a hand, and now he's using it to like fly drones, and like he wants
Wow.
to become like a commercial pilot. And so it's really exciting to see him grow and go into that. And then our second recipient, she is an occupational therapist, and she had a bionic hand, but her insurance said that she could only get one for her entire life. I remember what I said about those like hands breaking very easily.
Yeah.
So hers broke and she couldn't get it fixed, and she insurance would only cover one for her entire life, which makes no sense at
Yeah.
all.
That's crazy.
Yeah. And so through the Ability Fund, she was able to then receive our hand and then use it on a daily basis. So that was exciting for us.
Yeah, I mean, I think the magic is not measured by money. It cannot be measured by dollar signs. To enable another human being to fully experience, that's incredible. Okay, so let's see. So, I mean, we're doing a lot of things now, and I have a couple concerns and also full disclosure. I am an investor in Psionic, so you may take this as a little bit of my personal bias, but I want to be also try to be objective as possible. I mean, I don't know what the future is going to be like, so I have a couple questions for you. Is one is I know that you're a very ambitious person, and I remember that you said you want Psionic to be the next Tesla, and I fully endorse you for that. I'm behind you on that 100%, if not 100%, 10. But how are you going to do that? I mean, are you going to create a gigafactory like Elon Musk? I mean, that sounds almost impossible. I mean, actually, it was impossible to most people when he wanted to do manufacture Tesla in such a unique way and scale up. And, I feel like Sonic is also at the juncture where you want to scale up and it just looks like a mountain that you have to climb. What are some thoughts behind this?
Yeah. I mean, so one of the reasons why we moved to San Diego is that there's a strong relationship with like Mexico. So Tijuana is 40 minutes away from us. Mexicali is like an hour and a half away from us, where they set up maquiladoras where there's like plants that you can actually do like high volume manufacturing there. And one of the things that we're looking at is like, can we do high volume manufacturing? So for our next gen hand, can we do like 50,000, 100,000 hands like built in those facilities? And then we keep low volume manufacturing here in San Diego. But we're keeping our options open. We might even just open up a factory here in the States as well too, and then see if the economics work out for us to make those volumes of the hands here. And with the next generation hand that we're building, we honestly, the way we're designing it, we want to make it in such a way that if we might actually be able to have hands building hands
Yeah.
would be, yeah, which would be really cool. So that way we could have like a close to like, lights out facility, or like at least a highly automated manufacturing process to make hands. And so that's going to be that's all the initiatives that we're working on like for that next generation hand, so that like when it comes out, it'll be out of the gate running.
Yeah, you know what? It is not far out. I have seen 3D printing companies print their own components. One example of that is HP. It actually prints their own components for the HP printer.
That's awesome for the
Self-made.
FPL, like for the multi-jet fusion.
Yep.
Nice, nice.
Yeah. And also a lot of 3D printing company just in general wanted to do that because it's such a great marketing tool. Like if the stuff that you make, your gadgets work because the printer, you can actually use it on your own product. That's an endorsement of quality right
Yep.
there.
Yeah, exactly, exactly. And we've definitely taken videos of our hands like screwing in parts of like another hand using like an electric screwdriver. So it's doable, and I think that's going to happen in the future.
The other question I have is more philosophical is you work with the Navy and the military projects and stuff. What do you think in the future that how do you decide as a company where you want to go or where you don't want to go?
Yeah, and the thing is when we're working with the military and like the DoD, it's very particular in helping to restore function to veterans who have lost their limbs in the wars,
Hmm.
right? And we're very against weaponizing like our hands, because
Yeah.
in the business of building people up and not breaking them down, right? And so that's important for us. But what we see as being very interesting on like the robotics and industrial side is just that there's so many tasks that humans are doing that in these settings that are dangerous. So like a lot of these assembly line tasks, like forges, right? Like if you're trying to pull something out of a forge, and like you don't want to lose your hand doing that, but if you need a robot hand to do it instead, then that would save a lot of lives.
Yes.
So we're seeing a lot of these tasks that are dangerous starting to be automated so that it would save human lives. But also for a lot of these manufacturing lines, there are like large labor shortages to like build cars to like Amazon has like a bunch of like labor shortages there too, right? And so to be able to provide automation solutions for tasks there, to be able to like pick and place things and like pack them up and like stock shelves and things like that, then yeah, I mean, that's going to be exciting that we can then automate those things and then open up new jobs for that are safer and more interesting and at the more intellectually stimulating even.
I was just there's so many things going through my brain as you're speaking. One, I was thinking about maybe these hands can work in a sterile environment, in a pharma industry, doing biomanufacturing where you don't have to.
We've already been looking into some of those applications actually, so
Yeah.
stay
Well,
tuned.
what about musicians? Can your hand play music?
Yeah, so we have been collaborating with a group called Finis Musicae. They're based out of New York. It's the brainchild of an incredible woman named Charlotte Kemp-Mull,
Hmm.
and she basically is creating this robotic orchestra.
Wow.
And so she was able to take our hand and put it on a universal robot arm, and they had it play piano alongside like a human playing piano, and then a they have a robotic cello as well, and they built this like entire robotic orchestra, and it's just
My
fascinating to
God.
see. And it's so much fun collaborating with them
Is
because
there a video of that?
oh
I
yeah,
would
yeah,
love
yeah,
to
oh,
see it.
absolutely, yeah, I can send you it
I think
after.
that's like the ultimate test of the all the mechanical properties we mentioned in terms of speed, compliability. Is that how you say it? Compliance or comply?
Compliance, yeah.
Yeah, and all that. I mean, you have to stretch. I played piano a very short period of my time, and I hate it. But I enjoy the music. But it is really hard to be a master in this field, and a lot of it is very physical,
Yeah,
actually.
yeah.
That's fascinating. I can't believe every single vertical I could possibly think of.
I mean, that's the thing. Our hands do so many different things, right? Like it's ubiquitous. Everyone has them.
Yeah, it is amazing. I mean, I do believe that human for now is the best computer on earth. Is the human being. We're the best, better than quantum. Now we reached the end of this interview. I don't want to miss this most important part of this interview, which is who is the human, which is you behind this company. So now I just want a kind of announcement also that you're still raising fund currently for a Series A and you're looking for a serious lead investor, $5 million minimum, right? Okay, so if you don't have $5 million, I'm just kidding. You can still listen to this podcast. Now, okay, so I know these 10 years is hard and fun and exciting at the same time, but what are some of the habits that you have you think really helped you going through those hard times?
Yeah. I think it's two things. One is having grit, like just like when it gets hard, just being able to push through it, right? I mean, I'm to be completely honest, I'm working on average like 82 hours a week.
Yeah,
So it's more than two full-time jobs.
yeah. But more than a doctor, to be honest.
Sure. But the thing is that like, this is what I've wanted to do my whole life. And when we see the outcomes that we get with our
Hmm.
our human users, right?
Yeah.
Like to be able to play baseball, to be like, feel your daughter's hand, to feed your granddaughter for the very first time, right? Make a pinch for the first time in 35 years. That's why we do what we do. It keeps us motivated, it keeps us going, that everything that we do is for them. And for that reason, the second thing is just having gratitude. Like I've wanted to do this my whole life, and I'm grateful that I'm in a position that I get to do what I've loved and what I've had a passion for my entire life. Uh, and I think that it boils down to just those two things of just being able to like execute based on like grit and gratitude.
Hmm.
And as far as habits go, the thing is that I don't know, my job changes so rapidly that I think the one constant is being able to adapt to change. So maybe that's the habit, like being able to handle just things changing every single week. Like, I was in Indianapolis this week for like a health life tech health conference over there, and then I'm in San Diego for like a week, and I think that's the longest I've been here this year, right? Because we're at CES, at JP Morgan, at at all these different conferences. I was at a Shark Tank reunion as well. And so
Didn't know that existed. Okay. That
I
sounds
didn't know. I
fun.
didn't know until this year that existed as well. So it was pretty neat. But like going through and just being able to like adapt to all those different things and still keep going, I think that's one of the things that really sets apart successful founders for companies.
I do want to mention that every single email I get from you, I get even your team have the final, usually, at the end of the email, you always say with gratitude.
Yeah. Yeah.
Every single email from your team, I believe. And that actually does make a difference to me.
Yeah.
I don't know if you really said that with sincerity or not.
Yeah. And we mean it. Yeah.
And okay, for our younger audience, what are some of the habits or what kind of media consumption that you do at all these days? I don't know if you have time to read a book or blogs, or how do you get your information to stay current?
Yeah. So I feel like there's several avenues. LinkedIn, actually, we get a lot of our like news from LinkedIn, like in the field, like robotics news. Like anytime there's like a big robotics things happening, like, we usually see it on LinkedIn first. And I feel like my algorithm has gotten like really tuned on LinkedIn, where it's just like every single like piece of content that I get on there is like really useful, and just says what's happening in the industry.
Hmm.
So that's been a big one for me. And I guess we still, I mean, like, because a lot of this is still like cutting edge technology. We're reading like papers all the time, like from like Google Scholar, and so I've got alerts on that for
Yeah,
like things on like
Google Scholar is something I started to use this year because of this podcast. Several
Nice.
several founders have told me that's how they get their information.
Yeah. Yeah, it's great because it keeps me up to date on like every paper that's coming up that's relevant to what we do. And then attending conferences, right? So like we're at like all the prosthetics conferences, we're at all the robotics conferences as well too. And so we always see like the cutting edge like technologies in that front as well. But yeah, I mean, I try to find time to like read novels, but I don't know. It always I feel like I start a bunch of books, but I'm never able to finish them because and
Yeah,
then
I have that. I have a lot of them.
by the time I get back to it, it's just like I don't remember what happened anymore.
Yeah, I totally understand you don't have time for books. Now we're at the closing of this podcast. Do you have anything to say to our audience, the younger, how, in terms of as a entrepreneur, if they want to found a company, any advice?
Yeah, and the biggest thing is to just get out there and do it. Because the thing is, if you wait for a perfect moment, you're never gonna find it. There's never a perfect time to start. So you'd want to start now. And when we started, like we didn't know how to do like 1% of the things that we know how to do now, and we learned all of it just by doing it and making mistakes and failing and then just repeating and like really honing that craft, whether it was like mechanical engineering, electrical engineering, software engineering, like microcontroller programming, soldering things, like 3D printing, machining, all of that we learned outside of the classroom. And that's the best thing I could suggest is do things outside of the classroom, start building, and then document it. Make sure that you can build a portfolio online so people can see your work and what you
Mhm.
contributed to it.
Yeah,
That's something that we always look for whenever we're hiring.
that's an excellent advice. I'm going to share that with our interns as well. But thank you so much, Aadeel. I think I'm going to invite you back in the future because I feel like I'm on this adventure with you. And
And I would be happy to. Yeah.
and adventure means unexpected things to happen, sometimes good, sometimes bad. And
Yeah.
love to have a comrade on the road with you. Very exciting journey. So thank you so much for joining us, and I'll see you next time.
This podcast is for educational and informational purposes only. The views expressed do not constitute medical or financial advice. The technologies and procedures discussed may not be commercially available or suitable for every case. Always consult with a licensed professional.